Hey everyone, and welcome to This Explainer. Today, we're going to completely demystify the art and science of audio engineering. Drawing from foundational concepts in excellent resources like Sound Foundations and Optimal Reaper, we are breaking down everything you need to know to take your tracks to the absolute next level. We're covering it all, ranging all the way from the philosophical mindset of mixing right down to the literal physics of sound and electrons. Whether you're a seasoned producer or literally just setting up your first home studio, there is something really profound to learn here today. Okay, let's dive into our roadmap for today. Don't worry, we're going to tackle all these complex concepts in logical, bite-sized chunks. We'll be looking at 1. The art of Zen listening. 2. The 50-20-20-10 recording rule. 3. Demystifying audio impedance. 4. Gain staging in digital eras. And finally, 5. The magic of psychoacoustics. All right, Section 1, the art of Zen listening, or preparing the mind for sound. Before we even think about touching a dial, an EQ, or a mic, we've got to set up our philosophical foundation. I'm challenging you, right here, right now, to just be here. Listen with Zen ears. Don't let your expectations color your perceptions. Really let that sink in for a sec. You know, it is so incredibly easy to hear what we expect to hear, instead of what's actually happening in the room. Sound is just deeply subjective. So as an engineer, you've got to drop those preconceived notions. Stop relying on what you think that fancy gear should sound like, and start actively listening to the specific color your room is actually adding. Which actually brings us to this really profound realization. See, the physical movement of air molecules, those compression waves bouncing around your studio, that acoustic energy is entirely objective. It's just physics. But sound is this magical sensation that's rendered completely inside your brain. Sound literally only exists in your mind. And honestly, remembering this highly subjective nature of hearing, that is going to be your absolute secret weapon when we get to the final stages of mixing. Moving on to Section 2, the 50-20-20-10 recording rule, liberating your setup. Okay, we're transitioning directly into the practical side of recording now, and I am super excited for this part because we are about to bust a massive industry myth about expensive gear. I've got to ask you straight up, does an expensive microphone guarantee a hit record? We've all drooled over those catalogs, right? Thinking about dropping thousands of dollars on a single vintage tube mic. But is that really the secret sauce you're missing? Well, you can probably guess where I'm going with this. And this brilliantly illustrates the actual reality of the situation. 50% of your final sound, it comes entirely from the instrument and the player. 20% comes from the acoustic reflections of the room you're sitting in. Another 20% is dictated just by where you place the microphone. And finally, a mere 10%, yeah, just 10, comes down to your actual microphone choice. I mean, the player and the room matter infinitely more than the price tag on your gear. So what's the big takeaway here? First off, absolutely always focus on capturing an amazing performance first. Second, optimize your room reflections, use acoustic treatments, or honestly, just smart positioning. Third, spend some actual time experimenting with moving the mic around before you even think about reaching for an equalizer. Seriously, frame this rule not as some kind of limitation, but as a deeply liberating concept. It completely empowers home studio producers to get incredible professional results using the gear they already have lying around. All right, Section 3, demystifying audio impedance, the flow of electrons. Let's shift gears for a minute into the technical physics of electronics. Now, I know impedance can sound super scary and overly mathematical, but once you visualize it the right way, it's actually highly intuitive. So the crucial point here is understanding electricity through a really simple water analogy. Picture water flowing through a garden hose. Voltage, that's your water pressure, or the speed of the water. Current, or amperes, is the actual quantity of water flowing through. And impedance? That's simply the resistance. It's exactly like putting a nozzle on the end of that hose. If you tighten the nozzle, you restrict the flow. Impedance is just electrical resistance, impeding the flow of electrons. Simple as that. So how do we actually apply this in the studio? Well, when you're connecting amplifiers to speakers, you generally need matched impedance. That ensures maximum power transfer and keeps your amp from overheating. And hey, watch out for your cables. High impedance cables can literally consume power and permanently dull your guitar tone. But here is the massive twist. Microphones plugged into preamps defy this rule completely. No way around it. They actually need mismatched, high input impedance. We're talking usually between 1,000 and 10,000 ohms. This intentional mismatch preserves the signal's loudness and keeps the frequency response perfectly flat. It's a total reversal of the speaker rule.
moving right along to Section 4, gain staging in digital eras, managing levels and headroom.
If you're working in a modern DAW or a digital audio workstation, the rules of the game have completely changed from the old analog tape days. Let's look at the two eras side by side. Back in the analog era, engineers had to push their recording levels extremely high. Why? To mask the inherent hiss, noise, and distortion of the tape and the gear. But in the digital era, man, that old-school audio gospel will absolutely ruin your mix. Today, you want to keep your signal peaks way lower, right around -12 decibels. Doing this entirely avoids that nasty digital clipping and preserves what we call headroom. So, what exactly is headroom anyway? Basically, it's a safety zone. It's this built-in buffer you leave in your audio levels to make sure that really fast, unexpected audio transients, like the sudden sharp crack of a snare drum, can be accommodated without clipping and distorting your beautiful digital signal. Proper gain staging is entirely about protecting this safety buffer at every single point throughout your mix. Let's move on and see how this builds into making a massive sounding track. Because there's a really funny, ironic truth in digital audio. We actually use compression, which is quite literally gain reduction, to make our tracks sound significantly louder. Here's how it works. Step 1, we reduce the gain by squashing down those tall transient peaks. Step 2, doing that frees up headroom in the overall signal. And step 3, we can now safely boost the entire track back up using makeup gain. So the absolute peak volume hasn't changed at all, but the apparent average loudness of the track, it's vastly increased. It's a total game changer. And finally, Section 5, the magic of psychoacoustics, or tricking the brain. Okay, this is arguably the absolute most fascinating phase of the whole explainer because we're revealing how modern mixing is basically just psychological manipulation. Remember our Zen listening? Sound only exists in the mind. Let's anchor ourselves with this academic definition of a really crucial phenomenon, the Haas effect, sometimes called the precedence effect. It basically dictates that echoes or early reflections appearing within a specific time window of a direct sound aren't actually heard as separate echoes. Instead, our brains fuse them together, and we perceive them as one massive, thick part of the original sound. So what's that magic time window? It's 40 milliseconds. If an echo arrives within 40 milliseconds of the original sound, boom, your brain is tricked. Engineers exploit this incredibly specific threshold all the time to make a single vocal take or a dry guitar sound unbelievably complex, wide, and thick. It's like magic, but it's just biology. Now, what's really interesting here is that we can take these psychoacoustic tricks even further. For instance, you can dampen the high frequencies on an instrument to literally trick the brain into thinking it's physically farther away. Why does that work? Because out in the real world, air naturally dampens high frequencies over distance. By mimicking that exact physical property with an EQ, you create stunning 3D depth in what is otherwise a flat stereo mix. On top of that, by subtly boosting extreme highs and lows at quiet volumes, you simulate the massive power of a loud sound, even when the listener has their volume turned way, way down. So how on earth do we put all this together without just causing a giant muddy mess? Well, you've got to build a hierarchical flow. A lot of engineers will start with the bass guitar to really anchor the low end. Then they pocket the close-mic'd drums right in around it. Finally, they build up the remaining frequencies, actively carving out and taking away competing frequencies from different instruments. The whole goal here is to avoid masking. You want to make absolutely sure that every single instrument has its own dedicated physical space in the listener's mind. Which brings us right back full circle to our opening philosophy. If acoustic energy is the only objective reality out there, and sound only truly exists in your mind, what else in your mix are you simply imagining? I mean, are you actually hearing the brand name on your microphone, or are you hearing the true tone? Are you hearing your preconceived expectations, or the actual physical reflections of your room? Trust your ears. Drop your expectations. Take these principles of physics and psychoacoustics and go experiment brilliantly in your very next session. Thanks so much for joining me on this explainer. Keep creating.